So let's try our luck on the backward difference to see if it's any better. So I'm going to copy the file. I'm going to name it backward. And it should be backward. So instead of I plus 1, I want to I minus 1. So I minus 1 started with W end, and so I'm looking towards the left, right? And W1, well, to end minus 1, and I'll get rid of this. So dw dx should be W minus Wi minus 1. Everything else stays the same, right? Okay, so now we have the backward difference. So let's keep this figure to compare, and I'm going to say OD45 instead of forward. I'm going to be doing backward. All right, so it's done. Let's look at the workspace. Interestingly, OD45 decided to only take about 300 time steps as opposed to 1,000. So here we already see some kind of a non-symmetry, right? Forward, backward difference doesn't seem to be giving us at least exactly the same thing. And now let's make another figure, and let's plot our initial condition again. So that's our initial condition. Hold on, and plot the final solution in red. Okay, so here red is the solution after advecting over one period. So what do you see in the solution? Yes, some kind of diffusion, right? So it's not really solving the equation exactly, but after one period, it seems to have diffused, getting smoother a little bit. Well, which do you prefer? I would say the second one, right? Definitely. And so that's quite interesting, but like we still have one thing that we have not tried yet. So we have the central difference. Okay, central, and we need Wi minus 1 and Wi plus 1. So let's actually just copy the Wi plus 1 from the forward. Come on, forward. So here's my Wi plus 1. I think here's my central. Yeah, Wi plus 1 should be this. So dw dx is Wi plus 1 minus Wi minus 1 divided by, remember, 2 delta x, because I'm taking the average between forward and backward, right? Okay, so again, let's solve it with central. Okay, and I'm going to be basically repeating what I did over here. So I will just select what is in the history and press enter. So that's my central difference solution. And what do you see here? Huh? It matches a little bit better. Yes, I'd actually, it's hard to really argue which one is better, right? In some sense, if you can take an average, if you can smooth out the solution on the right hand side, it seems to actually match the analytical solution, which is exactly the same as the initial condition, a little bit better, right? But in terms of absolute value of discrepancy, it's very hard to say. Okay, so let's just conclude our observation here and then get to answer why this actually happens. Forward difference, we see that the solution goes up to 10 to the 85. Absolutely horrible. Okay. Backward difference, okay, we see a solution that seems to be smoothed out, right? But actually, it's at least it qualitatively seems to be similar to what the analytical solution should be. And central difference, the supposedly second order approximation, seems to be tracking the analytical solution, but it seems to be growing some kind of a wild oscillations. Not as bad as the kind of oscillations we see in forward difference, but still, it's oscillatory. It gets us some oscillations that shouldn't be there. So what's happening? Why are they doing that?